A team I work with once deployed a tiny, harmless looking fix at 3 p.m. on a Wednesday. They renamed a field in one API response, camel case instead of snake case. Two characters changed. By 3 or 4 p.m., a mobile app with 8 million users was crashing on launch. By 3:11 p.m., the support inbox had 900 new tickets. By 3:30 p.m., every senior engineer was in a war room. The code was fine. The new field name was objectively better. The deployment was clean. Test passed. What broke was something they hadn't even thought of as a thing, the API contract. And here's the punchline. Most engineers don't realize they are maintaining contracts at all until the day they break one. Then they realize the contract was all along the most important artifact in their entire system. More important than the code, more important than the architecture diagram. By the end of this video, you will know exactly what an API contract is, what's inside one, how to change one without burning down the city, and why the contract matter more than the code. Let's get into it. An API contract is the promise an API makes to everyone who calls it. The promise has a 4 parts. What you have to send, what you will get back, what errors means, and how it will change over time. That's it. 4 parts: request schema, response schema, errors, versioning. Notice what a contract is not. It is not the code. The code can change every commit as long as the input, output, and errors look the same to the caller. You can rewrite the entire backend in a different language and nobody outside your team will notice. The contract is also not optional. You have one whether you wrote it down or not. Every caller has built assumptions about your API. If you change those assumptions, their code breaks. The only choice is whether your contract is explicit, written down, versioned, agreed upon, or implicit. A fog of habits in everyone's head. Stick this in your brain forever. The contract is what you promise. The code is how you keep that promise. Confuse the two and you will break the world. The reason senior engineer obsess over contract isn't pedantry. It's that the contract is the only part of your system that other people built against. Your code is yours to change. Your contract is shared. Picture a restaurant. The menu in your hand is the contract. The kitchen behind the wall is the code. The menu tells you exactly what you can order, what's in the dish, what it costs, whether it's a vegetarian or has nuts. You can make decision based on the menu. You don't go back into the kitchen to verify. The kitchen can change anytime. New chef, new supplier, a faster oven. As long as the pasta carbonara still arrives looking and tasting like a pasta carbonara, the menu hasn't lied. You, the customer, don't care. The kitchen is private. The menu is public. Now imagine the restaurant decide mid-service to rename spaghetti carbonara to creamy bacon pasta. Same dish, better name, but every regular who walks in and orders carbonara is now confused. That's the breaking change to the contract. The kitchen didn't change at all, but the menu did. Now imagine you add a new dessert. Existing customer don't notice. They can keep ordering exactly what they ordered yesterday. That's a non-breaking change. You can ship those all day. And when the restaurant really does want to redesign the menu, they print menu version 2 while keeping menu version 1 available for a while. Regular get time to adjust. New customers see the new menu, both works. The menu is the contract. The kitchen is the code. Customers can adapt to the new kitchen overnight. They cannot adapt to the new menu without warning. That's the API versioning in one paragraph. There are 3 reasons every engineer needs to take contract seriously. Reason 1. The contract outlives the code. Your backend will be rewritten twice, maybe 3 times. The contract usually outlives every rewrite. Slack API today still serves client written 10 years ago. The code underneath has been replaced a dozen times. The contract is the real product. Reason 2. Bad contract costs real money. Every breaking change you ship trigger an outage somewhere, sometimes in your own app, sometimes in a partner integration, sometimes in a customer's batch job that runs at 2 a.m. and now silently fails. The bill arrives week later as bug reports you can't reproduce. Reason 3. The contract is your team's leverage. When you ship a clear, well-documented contract, every other team can build against it without asking you questions. When your contract is fuzzy, you become the bottleneck. Every change becomes a meeting. Good contracts are how engineering organizations scale without drowning in coordination. The contract is not a paperwork. The contract is the product. Here's where we are going. We will walk you through the 4 parts of every contract, then talk about changes. Part 1. The request schema. Every endpoint specifies what caller must send. Require field, optional field, what type each one is, string, integer, decimal, and enum from the fixed list. What constraints apply. A good schema is so precise that you could generate a client library from it. Tools like OpenAPI, JSON schema, and protocol buffers exist for exactly this reason. They turn the schema into a machine-readable contract. Part 2. The response schema. What the server promises to return when things go well. Which fields are always there, which might be null, what types they are. This is where most accidental breakages happen, because developers feel free to add or rename fields, forgetting that someone somewhere parses every field. Part 3. Errors. This is the part everyone skips. A good contract documents every failure mode the same way it documents success. A 400 with code invalid body is different from 400 with code validation failed. A 503 means retry with backup. Client should know that. If you only document the happy path, every error becomes a guessing game for your callers. Part 4 is versioning. How the contract changes over time. The simplest version is putting /v1 in the URL. When you need to break the contract, you ship /v2 alongside it. You announce a deprecation date. You publish a change log. Old callers keep working. New callers get the new shape. Now look at the breaking changes table. On the left, changes you can ship anytime. Adding an optional request field, adding a new field to the response, adding a new endpoint, loosening a validation rule. On the right, changes that break caller, renaming a field, removing a field, changing a field's type, tightening validations, adding a new required request field, changing what an error code means. The test is simple. Picture every existing client. If any of them would now misbehave, you have a breaking change. Either don't ship it or ship it under a new version. I want to be honest with you about something most courses won't tell you. The good news, once you take contracts seriously, your team moves faster, not slower. Contracts let frontend, mobile, and backend team work in parallel without waiting on each other. They let you test against mock servers. They let you generate documentation, client SDKs, and validation code automatically. The bad news is contracts are real work. Writing a schema is slower than just shipping JSON and hoping. Versioning 2 parallel APIs costs engineering time. The teams that win at this treat the contract as deliverable, not an afterthought. And here is what people gets wrong. They think versioning is the contract. It's not. Versioning is the rule for how the contract evolves. A team can ship V1, V2, V3 and still have terrible contract at each version. The discipline is in the 4 pieces: schema, errors, and rules for change, not the version number on the URL. 4 questions you should be able to answer after this video. Question 1. What's an API contract? 4 things: the request schema, what caller must send; the response schema, what they get back on success; the errors, every failure mode named and documented; and the versioning rules, how the contract evolves. Question 2. Why is renaming a field a breaking change? Because somewhere out there a client is reading that field by its old name. The moment you rename it, the client gets null or a parsing error or wrong data. The code on your server didn't break, your caller's code did. Question 3. How do you safely evolve an API? Add, don't remove. Optional, not required. When you must break the contract, ship a new version alongside the old one. Announce a deprecation date. Publish a change log. Give callers month to migrate. Question 4. Why does the contract matter more than the code? Because the code is yours. The contract is shared. You can rewrite the code anytime without telling anyone. You cannot change the contract without breaking everyone who depends on it. That last one alone will save you in the interview. Before you go up, take 30 seconds to log this in. Takeaway 1. A contract is a promise. 4 parts: request schema, response schema, errors, and versioning rules. Every API has one, written or not. Takeaway 2. The contract is what other people build against. The code is yours to change. Confuse the two and you break the world. Takeaway 3. Add fields, don't rename them. Add endpoints, don't remove them. When you must break the contract, ship a new version and let the old one die slowly. In the next video, we will get into databases, relational versus non-relational, the choice that shapes every other decision in your system. If this helped you, hit subscribe so you don't miss the next one. The full system design playlist is linked below. See you in the next video.